Topic 4.6, using Laplace transformations to solve differential equations. And the first question here deals with just how to split fractions using partial fractions, and that just allows you to use your Laplace tables. So for example, here I have 5 over x squared minus 1, and if I wanted to do a Laplace transformation, it'd be difficult on that one, so I'm going to have to do mixed fractions. So I know I'm going to have a and a b, and I put it over common denominators, but the common denominators have to multiply to give you x squared minus 1. So I'm just going to factorize my x squared minus 1. That's actually a difference of 2 squares, so that's x minus 1 by x plus 1. So I'll use those as my two things that need to be multiplied. So x plus minus 1 over x plus 1. Okay, so now we know that will all be equal to 5 over x squared minus 1. Right, so let's just work on this side here. So our normal process is to multiply our common denominators. So I'll multiply these two by each other, and of course that gives us x squared minus 1. And then the x plus 1 will multiply by the a, giving me ax plus a. And the b will multiply by the x minus 1, giving me bx minus b. And that will be equal to 5 over x squared minus 1. Now my bottom lines are the same, so that means my numerators must be equal to each other. So I've got ax plus, and I'll gather my x's together, ax plus bx plus a minus b, and that must be equal to 5. So I've got x's on the left, but you can see I have no x's on the right, so I could say I have 0 x's there. So I can say ax plus bx is equal to 0x, and I can say that a minus b is equal to 5. So dividing across by x there just leaves me with the equation a plus b equals 0, and the other one, a minus b equals 5. Okay, so we can just do sort of a simultaneous equation there if we wish. So I can say that a is equal to minus b, and I'm going to utilize that then in here. So everywhere I see a, I'll put in minus b. So minus b is equal to 5. So minus 2b is equal to 5. So b is equal to minus 5 over 2, or 2.5 if you prefer. And then now back to find our a. A is just minus b, so in this case a is the negative of b, so minus whatever b is. So minus 5 over 2, so a is just equal to 5 over 2. So if I want to write that as a partial fraction, I could write it as a plus b, so a is 5 over 2, or if you wish just 2.5 over x minus 1, and b is, where am I here, minus 2.5 over x minus 1. Alternatively, if I did want to use the fractions, seeing as a is 5 over 2, it's 5 over 2 divided by x minus 1, and that would be minus 5 over 2 all over x plus 1 there, of course, x plus 1. I can do that as well. So that would be 5 over 2 times x minus 1 minus 5 over 2 times x plus 1. And you can tidy that up as well if you wished. 5 over 2x minus 2 minus 5 over 2x plus 2. So look, whatever suits the situation.